Hello everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajlakshmi College of Arts and Science. In this series, we have discussed about the theoretical fundamentals of artificial intelligence. Today we are going Today we are going to discuss about the introduction to rule-based systems. A rule-based systems is a fundamental concept in artificial intelligence that simulates human reasoning through a collection of logical statements. It's known as if-then rules. So these systems are designed to draw conclusions or make decisions by applying predefined rules to know facts. So the main idea is straightforward. If a certain condition is true, then a specific outcomes or actions should follow. Such systems are commonly used in expert system, diagnostic tools, and decision support system. So the structure of a rule-based system consists of three primary goals. One is a rule-based, fact-based, and inference engine. So the rule-based, the fact-based, and the inference engine, the rule-based contains a set of conditional statements that represent expert knowledge. Each rules describe a relationship between condition and conclusions. For example, a rule might state if a patient has a high temperature and persistent cough, then the diagnosis could be flu. The fact base, also known as the knowledge base, holds all the known facts or input data about a particular situation. This data might come from user input, sensor, databases, or previous inferences. At the heart of the system is the inference engine, which applies reasoning to derive conclusion. It compares the conditions in the rules with the facts in the fact base and determines which rules are applicable. So the inference engine may use forward chaining, where it starts from known fact and apply rule to infer new facts, or backward chaining, where it begins with a goal and work backward to see if facts support it. Through the process, the system continuously updates the fact base and applies more rules until it reaches a conclusion or no more rules can be applied. Next, we see the types of rule-based inference. So, there are two types of rule-based inference. One is a forward chaining, another one is a backward chaining. So, forward chaining is a data-driven from facts to fact to conclusion. Backward chaining is a goal-driven from goal to facts. So, forward chaining and backward chaining are fundamental strategy used in rule-based reasoning. Forward chaining is a data-driven approach that starts from a set of known facts and applies inference to derive new information until a specific goal or conclusion is reached. Here, this diagram represents the forward chaining and backward chaining. Here, we know the fact and we move on to the conclusion. But in backward chaining, it's a goal-driven. So here, the goal and come to the facts. Next, we see the inference rule type. So in rule-based reasoning and formal logic, inference rules are used to derive conclusion from premises. Among the most fundamentals are modus ponens. So it's a rule types, there are modus ponens, modern tolerance, hypothetical syllogism, disjunctive syllogism. So first we see the modus ponens. It's a direct and common form of reasoning. If states, then if, for example, A implies B. So A is true, then we can conduct the B must also be true. For example, if it rains, the ground gets wet. If it raining, then the ground is wet. So next one is a modus tollens. So on the other hand, in a form of reasoning by contradiction, if states A implies B and B is false, then A must also be a false. For example, if the alarm was not set, hypothetical for example, if the alarm is set, the bell will ring. The alarm did not ring, the alarm was not set. Next one is a hypothetical syllogism. So here involving chaining implication. If A implies B and B implies C, then again A implies C. So here we are using the chaining implication. These rules allow for multiple step reasoning and it's functional in complex logical systems. Last one is a disjunctive syllogism. That is A or B is true. So if A is false, then B must be true. For instance, it is either Monday or Tuesday, and it is not Monday, then it must be a Tuesday. So again, we see the example for forward chaining. Here, the illustrate a simple example for forward chaining, a data-driven inference method in rule-based system. The reasoning begins with a known fact. In this case, A is true based on the fact. We apply a sequence of logical rules to infer new information. The first rule says if A, then B. So since A is true, we can conclude then B is also true. Next, we use the second rule. If B, then C. Since we just inferred that B is true, we can now conclude that C is true as well. The chain of reasoning leads to B and B leads to C. So these are the example for forward chaining. Next, we see the example for backward chaining. So a goal-driven approach used in rule-based system. The process begins with a specific goal with a determine whether C is true. They verify this, the system looks for a rule, then concludes C. Here it finds the rule if B, then C. Next, we see the applications of rule-based inference. Rule-based inference system widely used across various domains in artificial intelligence due to the clarity, transparency, and case of implementation. So the applications are expert system, chatbots, assistant, diagnostic system, decision support tools. So these are the application of rule-based inference. Next, we see what are the advantages and limitations of rule-based learning. So rule-based inference system offers several important advantages that make them valuable in many AI applications. One of their key strengths is simplicity. So they are easy to design, understand, and implement. Each rule is clearly defined in an if-then format, which makes the logic behind decision transparent. This also contributes to the interpretability. Next, what are the limitations in rule-based inference? This makes them less suitable for dynamic or data-rich environment where machine learning or adaptive algorithm are more effective. So we come to the end of this section. I hope you enjoy this section. Thank you.